Hi, good evening, everyone. Today, we take the next topic for practice, which is limit, continuity, and differentiation, derivative, for a single variable. For a single variable. Okay. We begin by talking about limits first. So, first of all, limit means what? Limit means that we are going ahead and we are approaching a particular number. Does not mean we are finding the value at that number. So when I say that x approaches a, it means x is going very close to a. If I say x approaches 1, it means x is going very, very close to 1. So, x can take the value 0.999999, which is very close to 1, or x can take the value 1.00000001, something like this, which is also very close to 1. So when I say x approaches 1, it does not mean x is equal to 1. इसका मतलब ये नहीं है. What I mean here is that we are going towards 1 from both right and left hand side. Right and left hand side माने क्या? That if this is 1, we are going towards 1 by taking values very close to 1 from here. This is 0.9999999, which is close to 1 from this side. Or by taking values close to 1 from here, like 1.000000. We are going towards 1. Either from left or right does not matter. We are going towards 1. We are approaching 1. Now, in this, we have something which is called as the left hand limit. Left hand means from my left hand. I think it's a mirror image. It may seem right to you. From my left hand, I'm going towards that number, right? So we say like this. X approaches a minus. Mane, I am going towards 1, but from the left hand side. From the left hand side. So we are taking all values close enough to 1, but less than 1, right? So here we mean that x is less than. If we are approaching 1, but taking values less than 1, we can take the value 0.9999. We can take the value 0.99999. We can take the value. So it can be as close to 1 as possible, but less than 1. Then it is called as left hand limit. Whereas when we talk about the right hand limit, it means that we are going towards. I think there are some annotations here. Can you just see? Probably I see some blue lines in between. Ek bari dekh lena, huh? Okay. So when I talk about the right hand limit, right hand limit means that we are going ahead and we are approaching that number, but from the right hand side, right? So right hand side means we are taking all values, but which are greater than 1. Which are greater than 1. So इसमें हम क्या लेंगे? It is written as a plus, right? And we are going to take values like 1.001, 1.00001, 1.0000001, जो भी है. Man, it has to be close to 1, but it has to be more than 1. Now, when does limit of a function exist? So that's the rule number 1 that we have. So a limit exists if one of these, what I'm writing is satisfied. What? So limit fx, when I go towards a from left hand side, is equal to when I go from a from right hand side, is equal to value of the function at a, right? And abhi, you don't have to write this also. We'll talk about this in continuity. Abhi ke liye we are just talking about limit. So a limit of a function exists. When will limit of a function exist? Limit of a function will exist when the left hand side will be equal to the right hand side. Then we can go ahead and we can say that yes, in fact, the limit of the function is existing. So this is called as existence of limit, right? This is the first thing which you have to remember. अब कुछ बुक्स क्या लिखते हैं ना, they represent this limit in a very different way. और वो इसको कैसे लिख देते हैं? वो लिखते हैं, and up to you, if you want, if you are clear with this definition, it's fine. But they say that, I'm writing the formal definition, the number L is the limit of the function fx as x, I am just writing जो भी ऊपर लिखा है in words, approaches a, written as limit x approaches a, fx equal to L, if, okay, I'll write everything in words only, for every number epsilon greater than 0, there exists, I'll explain this, a number delta greater than 0 such that if x minus epsilon, or you can just use some word a also, x minus a is less than delta, then fx minus L is less than epsilon. This is the official definition of limit. अब बहुत आसान है, क्या बोल रहे हैं? Let's understand. It says, so x minus a less than epsilon, ध्यान से समझना, x minus a less than epsilon में epsilon is a very small number, very very small number. x minus a less than epsilon, तो suppose मैं बोलती हूँ आपको कि a is 1. Suppose if I tell you x is 1.000001, तो बेटा what will be x minus a? x minus a हो जाएगा 0.00000001, एंड ये जो नंबर आया है इट शुड बी लेस देन डेल्टा, माने डेल्टा बहुत छोटा नंबर रहा होगा कि ये जो नंबर आया है इट इज, यू नो, द डेल्टा हैज टू बी इवन, आई मीन ये नंबर जो होगा इट हैज टू बी वेरी स्मॉल, क्योंकि डेल्टा जो है इट इज अ स्मॉल नंबर इटसेल्फ, and I want this gap between x minus a to be less than delta. तो in other words, ये वाला जो पार्ट है, in very simple word, ये बोल रहा है that x is approaching a. माने x and a का जो gap है, it is very small. The gap between x and a is very small. How small? Smaller than some delta. बहुत छोटा गैप है x और a में. माने we are saying that x is approaching a. वही तो हमने यहाँ लिखा है that x is approaching a. Right? Now x minus a को हमने absolute value में क्यों लिया है? Because it is very much possible कि x could have been 0.00, you know, x could have been 0.9999. तो x minus a would have been what in absolute value? 0.9999 minus 1. तो ये भी यही आता 0.0001 ऐसे करके, because we are finding an absolute value. तो it would have been some small gap. तो हम कह रहे हैं कि okay, x can be smaller than this a या x can be larger than this a, but उनका gap should be very small. That is exactly what this says, that x can approach a from left hand side या x can approach a from right hand side. माना वी आर गोइंग टूवर्ड्स दैट नंबर ए, ठीक है, x जो है x is going towards a, so if my a is 1 then x is very close to a, the gap between x and a is very very small. Then it says that the gap between function and limit should be very very small. माने जो value I am getting, the function that I am getting and the limit that I am getting, that gap should be very very small. If that happens, then we can go ahead and say that the limit of the function exists. So we can go ahead and show this graphically like this. So let's say I have a graph. This is my function. Okay, let's say I take a. And let's say मैंने यहाँ पे I am approaching a from both the sides. अब of course यहाँ पे I may have the value of the function. जब मैं a डाल रही हूं तो मेरे पास function का कोई value आ रहा है. Now what we are saying is that when I approach this a, चाहे left side से या right hand side से, so whether I take a minus delta, माने x का value जो है वो a से बहुत पास है but a से थोड़ा कम है, or whether I take a plus delta, a का बहुत पास है but it's a bit more than a, तो यहां से जो values I get function का, they should be very close to this, right? तो यहाँ पे this should just be f of a plus whatever epsilon we had taken, and this should be f of a minus epsilon. This is what the definition of limit is. माने जैसे जैसे हम a की तरफ आए from both the side, as we come towards a, जैसे जैसे हम a की तरफ आ रहे हैं वैसे वैसे हम function की value की तरफ जाते जाए. This is what the simple definition is. As you go from, as you go towards a from both the side, you go towards the value of the function from both the side. If that happens, then that is the limit of the function. Now, there are some properties that you must remember from exam point of view. तो वो properties क्या हैं? First of all, the property can be related to the addition and subtraction. So if I have a function fx and I have a function gx and I am finding their limit, then I can apply limit separately, limit fx and limit gx, right? Similarly, if I have a function fx into gx and I have to apply limit on their product, so I can apply limit separately on fx and gx. Similarly, if I have quotient rational form में and I have to apply limit on this, then I can apply limit on this and this separately. But just remember, क्योंकि ये rational form है, the denominator cannot be equal to 0. So limit gx cannot be equal to 0. ठीक है, and subtraction में भी I'll just write here itself. तो subtraction में भी it's true. ठीक है, so these are some standard limit laws that we have. Another thing which you have to remember, which is the L'Hopital rule. Then I'll give you some questions. L'Hopital rule says that there are some indeterminate forms. माने you can have a form of 0 by 0, right? Infinity by infinity, 0 into infinity, infinity minus infinity, 0 to the power 0, infinity to the power 0, 1 to the power infinity. Whenever you have indeterminate form, जब भी आपके पास indeterminate form आए, usually there are 3 things which can be done. और हम उन तीनों पे ही numerical करेंगे. So you can apply algebraic simplification. You can apply rationalization. And you can apply L'Hopital rule, in which we can talk about L'Hopital rule, but only after you study differentiation it makes sense. So in which we differentiate the numerator and denominator separately. I'll talk about this. How it works, we'll talk about that. Okay. So this is the three things which can be done. Now, एग्जाम पॉइंट ऑफ व्यू से बेटा कुछ स्टैंडर्ड लिमिट्स हैं जो आपको पता होना चाहिए. Some standard limits all of you should be aware about. ठीक है. The first standard limit which you have is sin x by x. माने एग्जाम में इतना टाइम नहीं है कि आप इसको डिराइव करने बैठो. So sin x by x, x tends to 0 is 1. Then x tends to 0, 1 minus cos x by x square is half. Then limit x tends to 0, 1 plus x to the power 1 by x is e. Then this is c, sorry, huh? Right. Then ln 1 plus x by x, limit x tends to 0 is 1. And limit x tends to 0, a to the power x minus 1 by x. This is ln a. Yes, this is ln a. So I'm quickly applying the L'Hopital. You should be aware कि इसमें फटफट अपने mind में you should be able to apply L'Hopital and get the answer. So this will be ln a. These are some standard limits which you can remember. I mean, जितना you practice, बहुत सारे questions में you'll see कि the questions can be quickly solved because you would know some of the limits on your own. Okay, so let's take the first question for the day. All of you try to solve this one. So question, limit x tends to 0, 1 plus 2x under root minus 1 minus 3x under root upon x, right? And the options are 3 by 2, 0, 5 by 2, 1. Give it a try. Okay, how about others? अच्छा, I have to give you one more question, ठीक है? Based on squeeze theorem, वो भी एक बारी करेंगे. So the moment we see these kind of questions, what we can do is पहले हम 0 directly apply करके देखते हैं. So we notice 1 plus 2 into 0 minus 1 minus 3 into 0 by 0. It's a 0 by 0 form. So I can either apply L'Hopital here or I can apply rationalization. ठीक है? Let's follow rationalization first. तो rationalization में हम क्या करते हैं that if you see a negative sign here, you will multiply numerator and denominator with a positive sign. तो कैसे करेंगे हम इसको? We'll say 1 plus 2x under root minus 1 minus 3x under root upon x into 1 plus 2x under root plus 1 minus 3x under root upon x. ठीक है? So this is going to go ahead and give me, so we use the property that a minus b into a plus b is a square minus b square. So we get 1 plus 2x under root whole square minus 1 minus 3x under root whole square upon, sorry, my bad, why I have written x here. This will be 1 plus 2x under root plus 1 minus 3x under root. Okay, so my denominator will be x 1 plus 2x under root plus 1 minus 3x under root. And x tends to 0. So I'll get 1 plus 2x minus 1 minus 3x upon x 1 plus 2x plus 1 minus 3x. Limit x tends to 0. So 1 and 1 will cancel out. 2x plus 3x will be 5x upon x 1 plus this plus 1 minus this. X and x will cancel out. Limit x tends to 0. Now just put the value of x. So 5 upon 1 plus 2 into 0 plus 1 minus 3 into 0. So this is going to be 5 upon root 1 plus root 1, 1 plus 1, which is 2. So answer will be, where did the options go? C, 5 by 2. अब या तो आप rationalization से कर लो, or you go ahead and you solve by the other method, right? Which is your L'Hopital rule. I am fine with both. Okay, now question number 2, beta. Any doubt in this one? Anyone? Take it. Next question. So you have to tell me limit x tends to 0, x square sine 1 by x is a 1, b 0, c minus 1, d 1 by 2. By L'Hopital use, yes. So you just differentiate numerator and denominator separately. So if I differentiate the numerator, what will I get? I'll get 1 upon 1 plus 2x under root, right? So just keep using the chain rule, right? So remember that when I am writing 1 plus 2x under root, that means it's 1 plus 2x to the power half, right? So power will come down, power will reduce by 1 into, remember that you have to also differentiate what is coming inside. So into 2, right? Similarly, if I differentiate this, this will be 1 by 2, 1 minus 3x under root. Into, you always differentiate whatever comes inside. So if this becomes difficult, please write this part as this. This will always make things simpler for you. So power comes down, power reduces by 1 into minus 3. You have to differentiate what is coming inside upon differentiation of the denominator. Don't apply quotient rule. You have to differentiate numerator and denominator separately for L'Hopital rule. Limit x tends to 0. Now just plug in the value half. 1 plus 2 into 0 is 0 to the power minus half into 2. And this will be plus 3 by 2 because this is minus and minus. And this will be 1 minus 3 into 0 to the power minus half. Right? So this is just going to be 1. This is 1 plus 0 is 1 to the power anything is 1. This 2 and 2 will cancel out. So this will be just 1 plus 3 by 2. This is just 1. So this will be 1 plus 3 by 2, 5 by 2. Okay. Is it clear now? Okay. So now let's talk about the second question. Again, there are multiple ways to solve this question also. I mean, it depends on how you want to solve it. So first of all, I will solve this using squeeze theorem. Listen to me very carefully what squeeze theorem says. Squeeze theorem says that if whatever I have, whatever function is given to me, it is bounded between two functions. And when I apply limit on these functions, I get the same answer. फिर से बोलूंगी. I have a function fx. Fx is between gx and hx. And when I apply limit to gx and limit to hx, I get the same answer. जो भी आंसर आ रहा है, you can get some delta. जो भी, you're getting the same answer. Then even for this function, the answer is that delta only. That is called as squeeze theorem. Let's try to see if that works here. So whenever we talk about the function sine x, whatever be the angle here does not matter. But when I talk about the function sine always is bounded upper and lower by 1 and minus 1. So when I would write sine 1 by x, this will always be between minus 1 and 1. Now, this is this part. But what is the function given to me? The function given to me is x square into sine 1 by x. Man, I need to multiply it by x square, na? So I will multiply x square on all sides. And I'll get minus x square less than equal to x square sine 1 by x less than equal to x square. I will check the limit of these two, the extreme functions. So when I check limit x tends to 0 minus x square, you put 0 in this and you get 0. And when you check limit x tends to 0 x square, you get 0. So the functions this and this, as x tends to 0, this also goes towards 0 and this also goes towards 0. They're going towards the same number. So it means that ये जो function है, ये जो gx है, it's approaching 0. And ये hx भी is approaching 0, जो extreme sides हैं. So the function in between, जिनके बीच में it is squeezed, must also approach 0. So therefore we can say that this x square sine 1 by x will also approach 0. All of you are right if you have said that the answer will be B. But you can definitely do this question by L'Hopital. Right? There is nothing wrong in it. Mane, you could have written this function as this sine 1 by x, or ये x square ko I can write 1 by x square. Right? I can write this as 1 by x square. So then also it is fine. And I can apply L'Hopital on it. So up to you how you want to do it. But yes, you're right that the answer will be 0. Okay. Now, so I'll give you an economics oriented question. Right? That's also fine. You can apply that. That's right. Okay. So consider constant elasticity of substitution production function with x and y as inputs. Then as rho tends to 0. Limit rho tends to 0. X to the power rho plus y to the power rho upon 2 to the power 1 by rho approaches, right, a xy, b root xy, c 1 by xy, d 0. Give it a try. Yes. So you can just differentiate numerator and denominator separately. Differentiation of sine is cos. Differentiation of 1 by x is minus 1 by x square upon 1 by x square. This will cancel out. This will give you minus cos 1 by x, right? And you can just go ahead and apply it. Oh, sorry, I didn't differentiate the denominator yet. So you can differentiate the denominator separately. So this will be x to the power minus 2. So when I differentiate it, it will be minus 2 x to the power minus 3. So this will be cos 1 by x into minus 1 by x square upon minus 2 into 1 by x to the power 3, right? So this will go ahead and cancel itself, right? And you will go ahead and you will get cos 1 by x upon 1 by x into 1 by 2. Okay. And you can just apply limit x tends to 0 on this one. Okay. How about others? How are you solving this? Sorry, this is the question. I'm just thinking there can be one more way in which we can solve this. I mean, as I said, there are many ways, but you could have done, I don't know if some of you tried it. This can be x into x sine 1 by x, right? And you can apply this property as well, right? So just think about it. So my whatever my angle is here, if I have sine x by x, if this is 1, limit x tends to 0, this is very well equivalent to sine 1 by x by 1 by x, limit x tends to 0 equal to 1. Mane, the point is that whatever angle comes here should come here. Whatever angle comes here should come here, right? So you could have very well used that property also. So you could have done this as x sine 1 by x by 1 by x. And then you could have said that since we are applying limit on product, it is limit of individual numbers. So limit x tends to 0 into x and limit x tends to 0 sine 1 by x into 1 by x. Just apply limit individually and get the answer. So again, there are many ways, up to you how you want to solve, but you would see that this example usually comes in the squeeze theorem example. Okay. Okay, just try this one. So this is a very interesting question, but if I start solving it, it is a 25-30 minute analysis. You may not have that much time in exam. You have to remember certain things from the point of view of exam. कुछ चीजों को याद रखना बहुत जरूरी है. So yes, for people who have taken log, you are moving in the right direction. माने अगर आपने ऐसे किया है, y is equal to x to the power delta plus y to the power delta by 2 whole to the power 1 by delta, and you have taken ln on both sides. You are moving in the right direction, but it is going to be a very hectic analysis, right? So just remember these kind of questions. कुछ चीजें आपको याद रखोगे तो ज्यादा आसान रहेगा एग्जाम में. That when we have this kind of constant elasticity of substitution function, it approaches its geometric mean. It approaches its geometric mean. Of course, you can go ahead and solve it. You can take ln m to the power n. 1 by rho can come here. It can be ln x to the power rho plus y to the power rho by 2. Of course, you can take limit. But जब आप limit लोगे, so you will see that here you will get 0. Right? And you will notice that here also, ये जो पूरा चीज बनेगा, this will become 0. Right? And this will also be 0. So it will be a 0 by 0 form. So you will apply L'Hopital and solve. I am leaving it to you if you want to try. So you will apply L'Hopital. L'Hopital करके you will solve this question. ठीक है? And then जो भी यहाँ पे आंसर आएगा, that will be ln y. तो y निकालने के लिए you will take it to the exponential power. So y will be e to the power whatever answer you get here. But पूरा solve करोगे, you will notice that the answer is actually coming out to be geometric mean. So it's a property. And just remembering this property will be a good thing to be done.